Welcome, everyone. Thanks for joining us. As you can see, obviously, we are actually live and things happen on live events that we are often unexpected. But thanks for joining us today for the third event in our series, which is focused on combustion performance.
Today, we're going to talk not only about combustion performance, but also the very real and significant costs associated with poor combustion, especially for businesses where most, if not all, of their products go through a furnace at least once. And again, whether that's an open fire or radiant tube furnace, a batch or continuous furnace, large or small, everything we're going to talk about can be applied to customers in big steel and aluminum, captive and commercial heat treating, and primary metals processing.
And of course, if you have any questions, go ahead and leave them in the chat section and we'll get back to them.
Before we jump into it, let's do a quick recap. In our previous live event, we discussed the relationship between furnace performance and business performance, especially when everything you produce goes through a furnace. So fundamentally, we like to think of it that furnace performance equals business performance. And additionally, we reviewed that combustion is simply chemistry, and because of that, there is a right way to run it. And when you don't run that right way, it can cost your business a lot of money. Then we discussed the difference between I think my combustion is running well and I know it is running well. We don't accept I think in any other critical situations, so why should we accept it in industrial combustion when safety, quality, delivery, and business performance are all on the line?
That's right. Remember, industrial furnaces are operating at very high temperatures, often in challenging environments, so they are constantly changing and degrading. And these combustion changes don't operate on a fixed schedule. So the only way you really know is monitoring combustion is really key to operating your furnace and your business optimally. And then we talked about a solution to monitor existing combustion processes. That's PS Energy's combustion monitoring and alerting system, which easily retrofits to existing open fire or radiant tube burner systems and delivers powerful data, allowing you to know that your combustion is running well. This is an example of the open fire monitoring dashboard. And really knowing that you're running combustion well gives you a firm foundation from which to make decisions and also to troubleshoot.
You watch a lot of things in your process. Why wouldn't you monitor the first step, which is making the heat?
Exactly, Taylor, right? Don't think, no. So if you missed those first two, check them out in our LinkedIn profile or on our website. And with that, let's get to our topic for today, the real costs of running combustion inefficiently.
So poor combustion directly impacts many areas of business that can be very costly, and we like to think in terms of safety, quality, delivery, and cost, always in that order because that's the order of highest impact on a business.
So let's start with safety. Here you can see a radiant tube. It's filled with carbon. Now, this is caused by a combustion process that's running way out of tune. It's running very rich. And when burners run rich, they're producing a lot of emissions, especially carbon monoxide. So poor combustion causes high emissions. Now, in this particular case, this customer has used our tuning services several times a year, but had not yet installed combustion monitoring. In this facility, CO alarms inside were going off, which was indicating a very unsafe work environment, which caused the production team to leave the work area, which of course led to unplanned downtime. So this furnace had to be shut down and production was stopped until our service team could get on site, make the proper adjustments, and get that process cleaned out and back to running combustion correctly.
So essentially, poor combustion led to high emissions, which led to an unsafe work environment, and that drove unplanned downtime. And in this case, the process was corrected and things went back to normal for a while because, as we've said, combustion's constantly changing. So there have been other situations where the problem kept progressing to legal actions against the company.
Yeah, and so those costs of unplanned downtime and defending legal actions are staggering and can often run into the hundreds of thousands of dollars. And really more significantly than that is the potential cost to your team if someone was hurt or sickened by a poorly operating process.
So had these furnaces been retrofit with combustion monitoring and alerting, this emission problem would have been detected and corrected way before it shut down the operation or impacted any of the employees. So what may be perceived on the surface as that's normal. This furnace is always making soot, or it's not a big deal that we're burning a little bit more natural gas because gas is cheap, it can really become significantly more costly when safety is impacted.
Right, so let's move on to quality. So here's some data from a two-zone batch furnace, 28 total burners. The zones are left and right of furnace. The graph is showing temperature on the y-axis and time along the bottom on the x-axis.
So the red and blue curves indicate temperature in zones 1 and 2 during a furnace cycle before implementing PS Energy's monitoring and our waste heat recovery solutions. And as you can see in the graph, the two zones did not achieve the same temperature throughout the process. And in fact, zone 2 never achieved the 1400 degree Fahrenheit set point.
So material on the right side of the furnace was processed correctly. Material on the left side of the furnace was not. And in this case, loads were often failed at QC and returned for reprocessing.
So looking back at the graph, the green and yellow curves show the data after installing CMA and waste heat recovery solutions. And as you can see, both zone temperatures are right on top of each other, and both zones achieve set point temperature at the same time, which eliminates that side-to-side variation inside the furnace, solving their QC failure problem. This was not necessarily a scrap issue. It was more about the cost of reworking the failed parts. So the real cost here is not just the rework, it's the cost of inspection, lost capacity because it was being used to rework instead of producing additional product, and the cost of quality issues potentially being found by the customer.
Right. We know that poor quality costs increase by an order of magnitude for each step away from the process. So 10x the cost at inspection, 100x the cost if it's found at a customer. That fact and the potential loss of business reputation if poor quality gets to a customer drives that real cost of poor combustion significantly higher when quality is impacted.
So in this case, poor combustion led to non-uniform temperature in the furnace, which led to the rework of materials, which led to lost capacity and potentially, if not caught internally, could lead to customer product failure.
Right. So in this case, the cost of poor quality caused by poor combustion for an automotive supplier is well over $200,000 for that inspection and rework.
Now on to delivery. These costs are often experienced by our customers and yet not necessarily recognized because they haven't seen the benefits of good combustion. They truly don't know any better without the data, and they don't know what they don't know.
We all understand what the cost of one load or 1 hour of production is in our operation. And by optimizing combustion and getting the most out of every BTU of gas you buy, you can obviously produce more. And this is really easily seen on a batch furnace, and it applies the same to a continuous process as well.
So for ease of viewing, this is the same graph as before. And in this batch process, the customer ramps up to 1400 degree set point and then starts a controlled process cycle. And as you can see, the ramp times on this batch furnace drop significantly after implementing CMA and waste heat recovery solutions. So this specific customer saw an 8-hour reduction in their ramp cycle. Cycle time to set point decreased 53% from 930 minutes to 440 minutes, which in this case allowed them to run more loads in the same amount of time.
Right. Before implementation, that poor combustion led to extended ramp times, which led to tons of wasted capacity. And this wasted capacity led to lower production rates through the furnace.
So there are 5 of these exact furnaces at this particular location, which gave the customer 8 additional cycles per month after implementing our CMA and waste heat recovery solutions. And that's 40 more total furnace cycles per month, effectively giving them an additional furnace at their facility. So the real cost of poor combustion is the loss of revenue and profit on every one of those additional loads. Each load represented roughly $10,000 of revenue or an additional $80,000 per furnace every month. So annually, that's over $4.8 million just because they got combustion under control.
And lastly, let's touch on cost. And We think about customer costs in two ways: variable costs and component failures. In variable cost, obviously the most obvious is fuel. In one particular example, we have a customer, continuous galvanizing line, that has a budget of $432,000 monthly for natural gas. And by maintaining combustion in the optimal range, this customer is able to save $30,240 per month, which equates to an annual savings of over $362,000. Now, this is a huge number, significantly higher than the cost of combustion monitoring. Yet without monitoring, this customer would have never known how poorly the combustion process was performing, and would never have found that significant savings. And don't forget the equivalent reduction in emissions as well. Now, in terms of component failures, the opportunity there is to stretch the time between failures and recognize those failures before they occur so that your downtime can be planned. In this picture here, you can see a pile of failed radiant tubes. You can see these tubes are cracked, split, pancaked, and warped. All of this is due to poor combustion. And each of these tubes costs anywhere between $9,000 and $15,000. So in this pile alone, there's over $120,000 worth of scrap. Utilizing the PS Energy solution allowed this customer to extend their tube life by 3x.
We actually have a recent example of a customer that's needing to replace 2/3 of the radiant tubes on their 60 burner roller hearth furnace. So in this case, poor combustion led to component failures, which were radiant tubes, which led to unplanned downtime and lost production. Each tube is going to cost this customer $9,000, adding up to $360,000 just for the replacement tubes. Add to that number the cost of removing the failed tubes, installing new tubes, as well as the lost production time to do all of this work, and the total cost of poor combustion in this specific example is well over $750,000. We've given a few examples of how poor combustion will impact your business performance in very real and significant ways, and you can see the business implications of not running combustion properly on top of those that we discussed in our last video. And these are big dollar amounts.
Yet we've really only just scratched the surface with these few examples. And hopefully we've opened your mind to the broader implications and really the magnitude that poor combustion costs have. And as Taylor said, these are big dollar amounts. And we like to think about, poor combustion is like an iceberg, right? What is easily seen is only the tip of the iceberg. There's so much cost and waste below the surface that's not easily seen, yet certainly could sink the ship. And the only way to recognize and truly eliminate those wasteful costs is to know you're running well, because you're monitoring combustion and getting the most out of every BTU your business buys.
And remember, if the product you sell goes through a furnace performance directly impacts your business performance. And we all know that furnaces are inherently inefficient and constantly degrading. So if you aren't continuously monitoring your combustion, you're really putting your business performance at risk.
So if you have any questions, feel free to comment or reach out to us directly. Thanks again for taking the time to join us today. Sorry about the live activity at the beginning there. We hope you learned something valuable and you're thinking about taking the next steps to monitor and maintain your combustion.
And if you're going to AIS Tech this year, make sure to come visit us at booth 1784 to meet our team and see some of the awesome tech that we have in action. We'll be giving 2 different technical presentations that take a deep dive into our waste heat recovery devices and our monitoring equipment. And as always, if this is something that you think would benefit your business, please reach out and we can help build the ROI for your specific combustion process. Thanks again, and I hope everyone has a good day.